This is MATHguide.com. My name is Mark Karadimos. Today we're going to take a look at chord-chord partial length relationships. First off, let's talk about what a chord is. This is what two chords intersecting a circle looks like. So let's talk about what a chord is. Well, as you can see, a chord is a segment, and the segment has its endpoints on the circle. So for instance, this chord right here has one endpoint here, another endpoint here. Since both of its endpoints are on the circle, we call that a chord. Okay, so you can see that there are two chords that are intersecting. In other words, they're crossing right here. So when we have two intersecting chords, we have a special relationship, which I'm going to describe right now. It turns out that if I take this distance, in other words, this partial length of the chord, and I multiply it by its other distance over here, it's got to be equal to this distance along the other chord times the other piece of the chord. Okay, so what does that mean? It means if you take the pieces of this chord, multiply them together, or find its product, it's equal to the product of the pieces of this chord. So to demonstrate this relationship, I'm going to put a problem that has actually lengths on the screen. So for this problem, we could see that there are two chords intersecting the circle again, right at this point. And it looks like this chord has pieces that have length 6 and 4. So if I find their product, in other words, if I find 4 times 6, it's going to be equal to the product of the pieces of the other chord, 3 times x. Okay, so the relationship says that if I've got 24 here and I've got 3x here, I then can use a little bit of algebra to solve for x. So if I divide both sides by 3, I'm going to get x is equal to 8. Okay, that was a fairly simple problem. Let's try another problem that gets more difficult. Here is example number 2. As you can see, this problem is more difficult because there is a binomial here and a binomial here. Alright, but the process still works the same. I'm going to take the product of the pieces of this chord and set it equal to the product of the pieces of this chord. So I'm going to take 4 times x plus 1, and I'm going to set that equal to 3 times x plus 5. And I'm going to do the algebra. So 4 times x, 4 times 4, 3 times x, 3 times 5. Okay, so to do some algebra from here, I'm going to subtract 3x from both sides. So I'm going to get 1x plus 4 equals 15. Again, continuing, I'm going to subtract 4, some simple algebra, and we're going to get the final answer, which is 11. So x is equal to 11. If we wanted to know what this actual distance is in this diagram, we could take 11. 11 plus 1 is 12. We could say if this is 11, 11 plus 5 is 16. And we could see that 16 times 3 is 48. 12 times 4 is 48. So everything is working. Alright, so that's it for this relationship for partial lengths of intersecting chords. So go back to MATHguide.com, check out our instructional videos, interactive quizzes, and text-based lessons. Take care.